Hi everyone, welcome back. This is Miss McConnell. Again, I'm going to be going over today's lesson, which is 1.7 literal equations. Our lesson overview is we're going to solve the equation for the indicated variable. The key is to isolate that variable and continue to show work and stay organized as we are solving for the variable. Now I'm going to meet you guys on slide 3 to go over your warm-up. So directions, we want to name one thing that is the same about each equation and name one thing that is different about each equation. Equation 1 is 2x plus 4 is equal to 8, and equation number 2 is xy plus c is equal to 8. So if you want to pause the video here and jot down in your notebook something that is the same and different, please do. Okay, so for one thing that is the same about each equation, you could have said that they are both equal to 8, or they both have a variable x in their equation. Name one thing that is different about each equation. Equation number 1 only has one variable, or you can actually solve for x for a numerical value. Or you could have said, looking at equation number 2, it has 3 variables and not just one. So now we're going to move on to slide number 4. So this is going to be the start of our shared lesson. So if you would like to take out your notebook and start jotting down notes, please do so. So a literal equation is an equation with 2 or more variables. Because literal equations contain more than one variable, we don't solve them for a numerical value. However, it is sometimes helpful to rearrange them to solve for one of the variables. So we are going to be rearranging today to solve for a different variable. Now, solving for that indicated variable steps, the first thing is if you see a fraction, we want to clear that fraction. Then we want to move extra terms. And then last, we want to divide. And the key here is to isolate the variable. Now we're going to head to our first example, which is on slide 5. I'm going to zoom in a little. All right. So, example number 1. The formula V is equal to L times W times H is used to find the volume of a rectangular prism with the length L and H height. Solve for H. So our first step is we need to figure out what we're solving for. We are solving for H. That means we want to rearrange the formula so we have H is equal to. Now, we always want to look to see if we can clear fractions. There aren't any fractions we need to clear here, but I am going to rewrite the formula. So I have V is equal to length times width times height. That is not a good H. And H. There we go. Okay, so we have V is equal to length times width times height. We don't have any fractions. Now we want to move extra terms over. Now I don't see a plus or a minus sign anywhere, so I can't subtract or add anything to the other side. But I do know that length times width times height are all being multiplied together. So how do I undo multiplication? I divide, and I want to get that H by itself, so I'm going to divide by the length and width, and whatever you do to one side, you have to do to the other. So then I am left with now V over length times width is equal to H. And now we have rearranged our formula and we have solved for H. So H is equal to V over length times width. Now, if you need to pause the video, make sure you have all these steps down in your notes, that's fine. But we are now going to move on to our second example here. So now we're going to look at example number 2. The formula E is equal to 1/2 kx squared is used to find potential energy E of a spring with the spring constant K that has been stretched by length x. Solve the formula for K. So what we need to know here is we are going to rearrange this formula and we're going to have it K is equal to, but first I'm going to rewrite the original formula. So we have E is equal to 1/2 K x squared. All right, now I do have a fraction, so I do want to clear my fraction. So because I have that 1/2, I'm going to multiply everything by 2 to get rid of that 1/2. So it gets multiplied to the E and to that 1/2. So I'm left with 2E is equal to 1/2 times 2 cancels out. And I'm left with K. Cannot draw K's on here. K x squared. Alrighty. Now, again, I am solving for K. So I have 2E is equal to K times x squared. Now, how do I undo multiplication? I divide. So I'm going to divide by x squared on both sides. So I can then just have the K by itself. So now I'm left with 2E over x squared is equal to K. And I have isolated my variable, so this would be my final answer. Again, I am just rewriting or rearranging their original formula to solve for K. Now I will meet you guys on slide 7. All right, now let's look at example number 3. We have the formula A is equal to B squared plus 2 times B times H is used to find the surface area of a pyramid with base B and height H. And we are solving for H here. So we need to get H by itself. Again, I'm going to rewrite that original formula. So I have A is equal to B squared plus 2B, that B is not again, 2BH. All right. Now, so we have A is equal to B squared plus 2BH. Now, that B squared is being added to 2BH. So the first thing I'm going to do here is I'm going to subtract B squared to the other side, just like you would a normal equation when you're solving for x. You always add or subtract first and then divide after. So now I am left with A minus B squared is equal to 2 times B times H. So now we are one step closer to isolating our variable h, but we still have that 2b being multiplied and attached to the h. So now we need to undo multiplication. So we are going to divide everything by 2b, because again, we want to solve for h, because that is what the problem is asking us to do. So now we are left with, when we divide by 2b on both sides, we are left with a minus b squared, that stays in the numerator, divided by 2b is equal to h. And this would be our final answer because we have isolated the variable h. Now we can move on to slide 8 here. So our lesson wrap up is remember to stay organized with your work. And the key here is to isolate the indicated variable. Make sure you find where it says solve for whatever variable it says, then you are going to isolate that variable, like in our 3 example problems that we did. And now you guys may begin your 1.7 homework.